Alright guys, welcome back to watching the notes. Hopefully you guys did well on your quiz. We'll go over those shortly. But today we are starting to talk about simplifying radicals because we are going to get into more solving, and when we solve we need to give exact answers, which means no decimals. No decimals, unless, like I said, the only time we usually use decimals are during those complex word problems where you use your calculators for them. But anything where I have radicals and I want you to give exact answers, you should not give me decimals. Alright, so there's two ways to do these problems. I'm going to show you the branching way just because later on that'll help us for other, when we have like third roots and fourth roots, which that'll be chapter 7 after the break. So here we go. We can break this down to 5 and 100. We could break this down to 10 and 10. Once you get a pair, you don't have to break down those 10s anymore, because then you get 5s and 2s. So I have a pair of 10s. That means I could pull a 10 out, but a 5 needed something to pair up with and it didn't have anything, so you can't pull it out of the radical. Okay? Basically what's happening is that this you can rewrite as the square root of 100 and the square root of 5. And the square root of 100 is 10, so it's 10 root 5. But if you don't see it this way, you don't know what your perfect squares are, you can branch it out all the way, circle your pairs, and then simplify. Alright, so if you have two radicals and you're multiplying, you can multiply them. So I have the square root of 48. Okay, that's 16 and 3, and 16 can be broken down to 4 and 4. Again, I have a pair. I don't want to break down a pair anymore. They're done. So this is 4 root 3 is my simplified answer. Okay? 12 and 6, 72, so 3 root 72. Do not forget the 3 on this one because it's in front. You want to break this down. 8 and 9. 9 is 3 and 3. I probably could have done this a better way. Okay, so that's 72 broken down. I have a pair of 2s and a pair of 3s. You multiply one number. Remember, you only take one of the numbers when you take them out. So when I circled these pairs, I only want to bring a 3 out and a 2 out. You need a buddy to get out of jail, but only one of you make it. That's basically how you think of it, to get out of that square root symbol. So we have a 3 and a 2. So I have my original 3. This is my original 3. Times 3 times 2. Those are the ones I brought out. Square root of what's left over, 2. So this simplifies to 18 root 2. Alright, with fractions, we cannot have a radical on the bottom. And this is the same thing as square root of 2 over square root of 11. What you have to do is rationalize the denominator. To do that, you multiply the top and the bottom by whatever's on the bottom in the square root. So I want to multiply by the square root of 11 over the square root of 11. And the reason is, when you multiply something by itself, now we have a pair of 11s underneath the square root, so it just becomes 11. And then this becomes the square root of 22. And 22 can be broken down to 2 and 11, but there's no pairs, so that is all you can do for that one. Can't break down that one anymore. So this is simplified of this. You cannot have a square root on the bottom. Alright, 25 over 3. Let's do that one. Square root of 25 over square root of 3. Well, first of all, what is the square root of 25? If you guys have something, simplify it right away. So this turns into 5 over the square root of 3. Now I have to, again, rationalize the denominator because I can't have a square root on the bottom. That won't be simplified enough for us. So our final answer is 5 root 3, because you can't multiply outside numbers into inside numbers, remember that, over 3. And that is your final answer. Okay. Alright, so let's do the next one. 18 over 13. Great, that's a big one. So square root of 18 over square root of 13. Now if it helps you to, if you want to simplify, there's two things you can do. You can rationalize or try to simplify the top to make life easier. The top, if you break down this 18, you get 9 and 2. And you get 3 and 3. I branched upward. It's okay though. So I have a pair of 3's, root 2. So this is 3 root 2 over root 13. The only reason I did that first is so that now when I multiply by root 13, it's not a huge number, which might make it a lot harder to simplify later. You still might have to simplify at the end though. So you get 3 root 26 over 13. And actually, you cannot simplify 26 anymore because it's 2 and 13. That can't be broken down anymore. So that's actually the final answer. So it actually worked out that I simplified it first. Alright, 2 more on these. Again, if it's the bottom one, I wouldn't simplify it. I would just multiply by it. So 5 times 12 is root 60 over 12. Okay, let's break down root 60. That's 4 and 15. And we can get a pair of 2's out of this. 15 only goes to 5 and 3, so it stays 15. Can't get a pair out of 15. So this turns into 2 root 15 on top over 12. Now, this is not simplified yet because notice the 2 is outside of the square root, the 12 is outside of the square root. 2 over 12 is a fraction that can be reduced. So this is actually root 15, or 1 root 15, over 6. I cancel the 2 and the 12. 2 twelfths is the same thing as 1 sixth. Alright, last problem on these. Multiply the top and the bottom by root 8. So we get 6 root 8 over 8. There's 2 options you can go here. You can break down this first, and then after that, simplify the fraction in front. So this turns into, so let me circle this in a different color. Root 8 is the same thing as 2 root 2. So what happens is 2 root 2 times 6 is 12 root 2 over 8. And again, that's just multiplying this by the 6. And now I can break this down a little bit more. These 2 numbers in front, 12 and 8, you can take divide those both by 4. So you get 3 root 2 over 2. Okay. The reason, again, why we're doing this is when we solve square roots, we want to get them into the nicest form possible. Alright, so here's the difference of what we were doing. Before we were solving by factoring, we did this before the quiz. Difference of 2 squares. This is 17 and negative 17. Because this is the square root of x is x, or x squared is x. Square root of 289 is 17. So we have a difference of 2 squares. So if I want to solve this, I set each piece equal to 0. And I get x is equal to negative 17. And I get x is equal to 17. That is how we solved those before. However, you can do that. You can do the same thing without factoring in these cases. If you solve by taking the square root, that means you want to just take the square root of x squared. But in order to do that, you have to move over the 289 first. So you get x squared is equal to 289. Well, take the square root. This is called solving by taking the square root. So you get x is equal to, when you solve and take the square root, you get 2 possible answers, plus or minus 17. Because when you take the square root, negative 17 times negative 17 can still get you 289, or positive 17 times positive 17 will get you the 289. So that's solving by taking the square root. Just move it over. It's like solving normally. Solving by factoring is factoring it and then setting each piece equal to 0. Alright, so now this says solve each equation. Alright, so I'm going to solve by taking the square root on most of these. So first thing you got to do is isolate the 4x squared. So I'm going to add the 6. So I get 4x squared is equal to 48. Divide by 4. X squared is equal to 12. Take the square root. You get x is equal to plus or minus root 12. I'm not done. This is not simplified. Always simplify your radicals. Again, 4 and 3, you get a pair of 2's. So it's 2 root 3. Plus or minus. Do not forget that. You should get 2 answers. Okay. Why don't you guys try a couple on your own, pause the video, and then come back and see what you get. Alright, so hopefully you paused. This one you subtract 3, so you get negative 5x squared equals negative 12. Divide by the 5, you get x squared equals 12 fifths. And then we do x is equal to plus or minus square root of 12. over square root of 5. Have to simplify that. So I'm going to multiply both the top and the bottom by the square root of 5. That's called, again, rationalizing the denominator. And then finally, 60 is 4 and 15. We did this one on the other page. Pair of 2's. So we get 2 root 15 over 5. And again, don't forget to bring your plus or minus. If you forget that in your final answer, it's wrong because there are two solutions. Okay, now, last two. This one some people get confused with because there's a parentheses. Just take that, you have to isolate the parentheses. So to isolate this parentheses, we have to get rid of this 3 first. So we get x minus 2 quantity squared equals 7. Now we can take the square root to free the parentheses. So you get x minus 2 is equal to plus or minus root 7. And now to solve for x, the final step, add 2. So we get x is equal to positive 2 plus or minus root 7. And that will be both of your solutions. Alright? Last one. Get rid of the 1/5 by multiplying by 5. So we get x plus 4 squared equals 30. Now you can take that square root to free up the x plus 4. Those will cancel. Only if it's grouped, though, will it work. So you get x plus 4 is equal to plus or minus the square root of 30. Now at this point, you have to think, can I simplify that? 2 and 15 give you 30, but you can't break down those more into pairs. So that's it. And then finally, our last step is subtract 4. Now, when we write these answers, I like to have the number in front of the radical. So this will be a negative 4 because we moved the 4 over, and it's minus, plus or minus the square root of 30. So that would be the exact answer for this problem. Okay, again, if I should not see decimals. This is all by hand. You can use your calculator to figure out, how things break down, but that's about it. All right. So, last two, using a falling object model. This is falling, not throwing. We're just dropping. So this is just the model that incorporates gravity. All right. The height is the standard height. The initial height is h. Okay. So HO is original height, where it started, where it was dropped from. H is the final height that you want, depending on where you are at. So it says a coyote is standing on a cliff 254 feet. Right there, that means HO. Above a roadrunner. If the coyote drops a boulder from the cliff, how much time does the roadrunner have to move out of the way? Now, we can use the calculator for this. Oh, and these ones, like I said, with word problems, I can get decimals. Just give me the decimal to 3 decimal places. Okay, so let's set this up. I know h, so we don't know. Well, I'm going to just set this up. Negative 16t squared plus HO. My original height is 254. My final height, well, if it's dropping it onto the ground, my final height should be 0, right? That's where I want it to hit. Negative 16t squared plus my original of 254. We can solve this one by hand. We don't need the calculator. And when I say we don't need the calculator, I mean we don't need to graph it and look at this, because there's no middle term with a t. And then divide by 16. So we get 254 over 16. And you can just leave that. Now think about it logically here. When we take the square root, we can technically get 2 answers. But do I want negative time? Hopefully you are all shaking your heads right now at your computers and going, no way, no way. We should not be using negative time. So I only need the one answer. So take the square root of this fraction in your calculator. You could just type it in, the square root of that fraction. And you should get t is approximately 3.984 seconds. Again, this is the only time it's acceptable to use decimals, are problems like this. I do not need an exact answer. Alright, and last problem. How long will it take an object dropped from a 575 foot, so that's the original, and I want it to end at 235 feet. So, my ending height is equal to negative 16t squared plus the starting height. Alright, so we're doing the same thing. I get negative 340 if I move the 575 over, equals negative 16t squared. and then you divide and take the square root. Okay, so when you do that, you get t is approximately 4.610 seconds. Okay, so those models are important. We are also going to learn throwing models and doing a bunch of other different models with quadratics later. But right now you can solve these models by just solving by taking the square root. Okay, and notice all these problems with taking the square root only have an x squared term. They do not have a regular x term in them. Remember, you need to factor or use the quadratic formula or complete the square for those, and we'll get more into that later. Okay.